Okay, we're doing a little bit of line boring today here. This is again, this is obviously a a setup for portable line boring. This is something I've been doing for a while. I go out and do portable type line boring and things of that nature. Again, it's all ties in with the heavy equipment and stuff like that. And this is my setup for the portable line boring. I'm in the shop now, of course. It can be done portably, but it'd be the same setup no matter whether you're on the road or in the shop. And essentially what it is just for a worn bore that's either well, again, excessively worn or egg shaped or otherwise damaged. Try to get in here a little bit if I can. Well, that's about as good as I can do for the moment. And and what I'm doing naturally is in this case I'm going to bore this out way oversized, and then I'm going to I'll go to the lathe and I'm going to bore the entire thing through. And then I'm going to make a sleeve, and then I'm going to push the sleeve in just a slight, ideally you shoot for like a slight press fit on the sleeve that I'm going to put in, and then the sleeve will be bored to accept the new bushings that'll go in it. In this case, it's going to be this type of bushings. They're going to be stacked. Though that's a 5-inch bore, it's 5 inches across here. The finish size, the actual pin size, I should say, is 3 inches. So the OD of this spring, I call these the spring sleeve style bushings, is 3.5. So what we shoot for, I'm going to shoot for. I like to have a decent wall on the bushing, so I'm going to shoot for approximately a 4-inch hole in the bore here, which is going to be fine because again we've got plenty of meat on here. You can see the way this factory boss is welded in, and there's plenty of meat. So the sleeve will be a 4-inch ID, 4-inch here, OD to fit in here, and then the sleeve will be bored for 3.5-inch. And again, you've got a few. The nice thing about these spring sleeves is you've got a few thousands you can play with. It's not like putting a traditional, like you'd have in an excavator, a hardened bushing, pin bushing in there, where you've got to get it, within, a 1,000th or less dimension in order to get the proper fit, or if it's too loose, naturally it's just going to spin again. If it's too tight, you actually can't get the pin in because it will collapse the bushing. These are a little more forgiving, let's say. So and again, since this is a 5-inch bore, this one's a little bit different. I have some footage. I'll include that at the end of this. I have some footage of an exactly similar knuckle to this one that I did a day or two ago. Same process. The bore, though, what it did, it had these go straight through. These get stacked in here. This is a 5-inch bore, but it's only these are 1 inch wide. These spring clip bushings. It only gets 4 of them. So what it is in the middle, I've already bored it out. You can't see it because it was walloped. It was all folded over from being pounded and this bore being elongated. There is a shoulder in there. The shoulder, in other words, 2 of these will go in from each side. You'll have 2 and 2, and like I said, and then you'll have about a 1-inch shoulder in the middle. I think the diameter of that, again, it's not important. The pin is going to be 3-inch, so as long as the diameter of that is slightly over 3, we'll be fine. So what I'm going to do is when I create the sleeve, I'll turn the sleeve up on the lathe, of course, and I'll bore it from each side, 2 inches in, or 2 inches plus a little bit, and leave that approximately 1 inch in the middle. With a step, in other words, it'll have a step in it so that it acts as a stop, so that these 2 bushings will only go in, a certain amount, and then they'll stop and they can't, fall into the middle. So that's what I'm doing here. And this is my setup. I use this is a commercial setup. This is the York brand of line boring. setup. I thought about, you know, I'll do it at some point where I video the whole thing of how you set it up and this and that. It's not a complicated procedure. Essentially what you do is you put the bar in through the bore, and you use line-up cones if it's not so bad from each side. You put a line-up cone on the bar, and then you have a collar that you would use against the back of it. And then on this side, because again I'm always working alone, I made this collar. It wouldn't normally have this. I made this. I put this on the second side of the collar, and then I tighten this down on the bar. and then what I do is I crank this out to get the cones tightened against the bore. Now again, that's all fine, assuming your bore is not too beat up. When you have an elongated situation, actually this is slightly along, you can see in here how the pressure was wearing the nose of this. So I was able to do this with the cones still. What I did is I just kind of, I'm mindful of, I'm watching how the cones, I make sure I deburr as best I can the good part of the bore before I put the cones in and line them up. And then I just, you know, just to make sure I'm seeing where the gap is. And then I sock it down evenly. Sometimes I'll shim in here with some sort of thin shim material. Sometimes you can actually get away with a piece of thin corrugated or something. So, and then you've got your heads. The heads, these are double bearing heads. I like to use a double bearing head on each side. It helps to cut down on the chatter. I know you can get away with singles. Sometimes on a long bore, I'll do that. These, of course, are exceptionally short bores. But you know, if you're going between 2 points and it's a long distance away, you may need to have a head bearing, and then an intermediate carry bearing, as a carrier style bearing, which is nothing more really than a flange bearing, but just to control the chatter. If you have two points apart and they're, you know, some distance away, you know, this is very prone to chatter. All of these setups are very prone to chatter, so you do have to be careful with that. In fact, in some of the other footage of the small one, the bore was much smaller. This is a 2-inch bar, this particular bar that you're seeing here. I had to do it with a 1.25-inch bar, and that gets prone to chatter. So what I'll sometimes do is, you know, I'll hang some sort of counterweights on there, you know, this and that, little things you can do to hopefully counteract that. But yeah, that's what I'm doing, and I'll bring you through this as I go. I'll shoot periodically, but yeah, this is essentially where we're at. And then, of course, these knuckles, there's a much larger part that these attach to, a big boom on the machine. It's a huge machine. It's a road cutting type machine, and I think I'm going to have to probably go out and do the boom part that these knuckles actually attach to. I'll try to, maybe if I can work that in, I don't know, it's usually hectic when I'm doing this on the road, but I'll try to actually get some footage of the actual boom later. But again, like I said, I'll bring you through this, just the boring part of it. You know, I'm not gonna get too crazy because I don't call it line boring for nothing, right? But again, the situation here is what I'm trying to do now is I'm just starting, I'm just by eye, just coming in, you know, guesstimated, you know, whatever, 40, 50, 60, 80 thousandths at a time by just, you know, moving the tool out. Let me zoom in a little here and going through. The type of tool I've chosen here, I use mostly pretty much all brazed on carbide. Sometimes I'll use a high-speed steel. It depends if it's a particularly rough bore. You may have to go back to high-speed steel or whatever. But I use mostly brazed on carbide, and I'm using this type of a tool because you want, again, these things are prone to chatter. This thing's just floating in the air essentially here. Okay, yeah, I've got it. You know, I've got the piece welded to a piece of, what is this, 8-inch channel iron, and I've got the channel iron clamped to the forks and this and that, but you can still get, you know, I mean, this thing, you know, as you get higher in speed and stuff, you can see it will get some what would you call it, resonance in it, and it will, you know, it is prone to chatter. I mean, you know, So you know, it can be tricky. Yeah, so that's about it. So once you get down more towards your finishing cuts, the tool port, well, I'll show you that later. The tool port has a way to adjust it. You see these, I don't know, can you see that? Yeah, there is hash marks here. Let me zoom in a little here. There is hash marks on the tool port, and then you have an open set screw that will go in here. These are threaded, these tool ports, and then the keeper is of course on the top side, so you will put in I'll show you this as I get along, and there's a tool, an adjustment tool to you know, to gauge this, and then you lock down your tool holder set screw and you go from there. Like I said, right now I'm just coursing this thing through, so I'm just literally doing it by eye. I'm only using the hold down screw for the tool, and I'm just bumping it out again because it's not critical, because again I've got a long way to go here, and I'm just right now, like I said, I'm just trying to get this thing back to round so that we can kind of begin the actual bore. I know it looks like we've made some chips already here, and I have. I mean, because, you know, again, there's a lot of material to remove. I've taken, as I said, there was that 1 inch wide shoulder that was in the middle here. It acted as a stop, so I've already bored that out, and now, like I said, I'm just starting to, I know it's a little dark, just starting to get to the point. Here you go. You can see, I think you can see, where it's just starting to get to the point now where we're getting into the elongated section. All right, this is a few passes later. You can see, well, maybe you can see, it's a deep bore. This thing's almost 5 inches long. You can see that we've got a cleaning cut pretty much all the way around this thing, except for way up at the very, very top. I'm using my flashlight there. Way up at the very, very top here, around here, and then on the other side, it's the same thing right up in here. Again, that explains, this is looking at it now naturally from the side, that explains the torsional forces that these things are under. In other words, all the wear happened essentially, you know, right about in here where the, you know, the piece that couples to this thing is, you know, pulling it and pushing this way and this way. So, you know, naturally to get it round takes a bit of doing, but I think the next pass obviously will make us full round, as I like to say. It'll be a full around cut, and we're doing okay here. Like I said, we've taken, you know, we've been through this, you know, a few times now. We've got, you know, a decent amount of chips coming out of it, and you know, and it's going fine, you know. So yeah, that's where we're at. So once I get it into full, you know, into full round, then I'm gonna make I'll start making my measurements, and and we'll see how close we are. And I bet you I won't be too far out, and I'll show you how I measure it with the, you know, the through the bar measuring tool, and then we'll start seeing how close we are, if it's time to start making finishing cuts and, you know, getting our numbers squared away, or if we're going to have to do some more boring. But I'm thinking we're going to be pretty close. So let me make one more cut just to clean this top away, and I think we'll be pretty good. We'll come back. Okay, I hope you can hear me over the drive motor here. As you can see, we're kind of into our finishing cuts here. Sped up the speed, and I've kind of slowed down the feed a little bit, taking a smaller chip, but like I said, we're now into our finishing cuts here. So I'll let this pass finish. It'll take a couple minutes naturally to come through this bore, and then I'll show you how I measure it, because like I said, we're starting to get close now. I'm probably going to be, after this pass, within 75 or 80 thousandths of where I want to be. So like I said, I'll let this finish and I'll bring it back, show you how I measure it. Okay, I've made another pass through the bore. I'll show you that in a minute. I'm on my finishing cuts now. I've made the pass through the bore, and then I retracted the tool. Here's the tool. I kicked the bar into neutral. Like I said, I kicked the bar into neutral. I've retracted the tool. Now here is how, let me put this in frame. Here is how I'm going to make my measurements inside the bore without naturally having to disturb any of the setup here. What you do is you just get it close. These are essentially just indicator parts, and there's a spring-loaded piece in here. So what I do is, this is the way. It's just kind of like a spring from a pen almost. So what you do is you get it, you get yourself close, and then what I do is I start by retracting it all the way, and I cinch it down with that little set screw. Come in a little closer here so you can get the whole idea. But the beauty part of this, of course, is that now, like I said, since I've retracted the tool, I have plenty of open tool ports here. These are designed to fit through the tool port. So what I'm going to do, and again I kick the bar into neutral, so I put this into an open tool port on the bar. Naturally I got to get one that's got all crap in it, right? Okay. I put this in a tool port in the bar, and then what I do is I face this set screw at me, and then what I do is I merely return this back into the bore. Well, I guess I can do it with there's a rapid traversing feature on here. So what I'm going to do is essentially send this thing into the bore, and again now this will be of course undersized of the bore. So I'm going to send this into the bore, and again it's not too critical as to how far in you go, because it's a through bore. And then all I'm going to do is I'm just going to take my little tool here, and I'm just going to release. I'm sure you heard that. It actually sprung and set itself in the bore. Well, you know what? Let me take this off and show you. Okay. There you go. Let's see. Let me zoom out a little here. Can I do that? There we go. So there it is. It's in the bore. Like that. And so now that it's in the bore, I'm just going to because it's got the tension on it from the spring, now I'm going to take this and I'm going to tighten it where it is. And then, let's see here, I'm just going to retract the thing from the bore. Okay, and then I'll remove my tool from the bore, and now I'll measure it. And that's how I get my measurements. Oh, let me show you the bore's coming out pretty good. It's let's see, let me zoom in a little. I don't know how good I can get it really. Maybe if I put a flashlight in it you can see. Yeah, it's maybe a little better. Yeah, it's not bad. I mean, and again, this doesn't have to be like a very fine finish, because again, this is getting bored, and then on the outside here, what I'm going to do is I'm going to, I'll show you how it has to all be done by hand. I mean, I'll use the machine, but I'm going to feed it by hand. I'm going to step this and counterbore this, essentially, for the first, whatever, eighth or so of an inch, and that's going to give me plenty of room and still leave plenty of meat to when I put the sleeve in. Again, I'm going to shoot for a light press fit on the sleeve that I put in there. And then, like I say, I'll counterbore this, and then I'll chamfer the sleeve when I make it. So when I pull that through and I push it in there, it'll give me plenty of room that I can, by counterboring this, I can weld. And I usually weld it in, equidistantly 3 spots around. And that way, like I said, between the fact that you've made it a light press fit and the welds, it's not going to go anywhere. And it also makes it so that it is metal. It's not weld metal. You're not relying on weld metal. Yes, I have a bore welder, and I know when people talk about line boring, they normally associate it with a bore welding operation, and you bore it, you weld it, and then you bore it to size. I got to be perfectly honest with you. I'm not cracked up about that. Let me show you. In fact, here's these plates. The way these head bearing plates are, The reason they do them this way with this teardrop shape, let me see if I can zoom in. You see that hole, that threaded, it's a 5/8 threaded hole on that head plate? That's for the bore welder. And yes, I have a bore welder. Not one of the great bore welders. It's a Bore Tech. It's not the higher end model. It's the lower end model. And that's not by mistake. When I first started doing this, line boring and stuff like that, I was never a fan of the boring, welding, reboring thing. Because weld metal is weld metal. It's not, I don't know, what should I call it? Parent metal? It's not metal, it's weld. And now there's a lot, there's a fair amount of guys doing this line boring and bore welding, and that's their answer to everything. Just come out, bore it out, get it to this, cut a couple of passes through it, get the hard crap out of there, weld it up and rebore it. Well, I've been doing this a good long time, and that always seems to fail very, very quickly. Yes, I will do it. I will bore weld, but not. I often advise against it, and I suggest that we do this: that we sleeve it, and we weld this. We can weld the sleeve in place or whatever, or maybe sometimes open it up, and there's no reason you can't. I shouldn't say no reason. There's usually a way that you can, with a little engineering, a little ingenuity, you can bore it out and get it back to the factory dimensions for the customer. Yeah, it takes a little longer, but I don't know. This to me is welding and machining work. This is not a race. So I mean, yeah, I'd be the first guy to say, look, if you're one of those people where you got 16 guys standing around, you just screwed up the end of your excavator, and you think you're going to call me, and I'm going to come in there and in 4 or 5 hours, bore, weld, and rebore this thing, slam the bushings in, and go back. You know what? Get another guy. I'm not your guy. Again, when I do one of these things, I expect it to last a good long time. And from my experience, it doesn't seem to last as long when you put the weld in, a bore weld in there, as opposed to actually making a sleeve out of a legitimate material, even if it's a 1018 or whatever, and fitting it and welding it in there, or pressing it in there, and having that parent metal in there. It just does not seem to last as long. I have done jobs behind the guys who have bore welded them, and you know what? The difference in money between a guy who's going to come out there and do a bore weld and a rebore and fit the bushing in, and between what I do is negligible at best, and it just doesn't seem to go the distance. So I try to not do bore welding for the purpose of something like this. I try to just, again, fix it with a proper machine sleeve and this and that. Yeah, sure, it takes a little longer, but I believe the results are always much better. All right, so anyway, I know I got sidetracked there. I'm going to take my measurement. And then we're going to see how close we are. I think I'm going to be within, I'm starting to get, like I said, this is into my finishing cuts here now. I think I'm going to be within probably 60 or so thousandths of this, so probably just another couple of passes, and then we're going to be good. But I'll bring it back and let you know where we're at. Okay, I wanted to show you how, now that we're getting to the finishing passes, I wanted to show you how do you get it dialed in, when it does come down to a critical measurement there for, a couple of thousandths, or, well, sometimes it's a thousandth if you're putting a traditional, hardened style bushing in there. You've got to be within a thousandth or so, and like I always say, the line boring comes down to the last, 2 minutes of the job. It's that last pass, that really is the critical part. And the way you dial it in, and it's pretty darn accurate, I got to tell you, is you see that. Let me zoom in a little more. You see that hash mark that comes across the tool port there, where there's that hollow. There's the hollow. Let me get something more pointy here. There's that hollow set screw there. And there is this hash mark that runs along the tool port here. That tool port's threaded. You put a hollow set screw in there. Now, the reason that's like that is because, let me show you this. This tool, there it is. This tool is what you use, I should say, to get your final, your final, there's a lot of glare on that, isn't there? You get your final dimensions with this. You see these hash marks on this tool here, and it's essentially, it's just like a lathe. What you do is you line these hash marks up with the hash mark across the bar, and then what happens is that you you dial that in, and it's essentially, like I said, it's kind of like a lathe in that one strike on this thing as you turn it is going to equal 2/1000ths on your full diameter. So, and it's, there's a little bit, there's bigger marks, as you see there's a character there, and then you got 2, 4, 6, 8, 10, and then there's another character. So it does break it down for you. It's, between each one of these large marks. So that's the way you do it. And like I said, essentially what you're trying to keep in mind is that one strike on this thing is going to equal 2/1000ths total diameter. So that's how you dial it in, is you take the, you loosen up the tool port, you loosen up the tool with the, with that screw there, all that does is hold the tool. So you loosen it up, and then you stick this tool into the tool port, into the hollow set screw. Let me bring this around so I can actually get the thing in there. And you move it along your strikes, you twist it along, and you count your strikes, and then and then make sure, what I do is, because this thing now, nothing's holding this, because you need the room to adjust it, you gotta remember to take that tool and seat it back down onto that, that hollow set screw, and then tighten this one so that you've got a true, mark on there. So that's how you adjust that. That's how you get it pretty well dialed in, for your finished cuts, and it's pretty accurate, based on, if you follow these hash marks, it works pretty well. So like I said, let me try to make some more, at least one or two more passes through this, and I'll bring you back. Okay, I've taken now what is going to be my final pass on this. Let's see, and you can see the tool here, the tool bit. Try to look in the bore. Let me see if I can backlight it with a flashlight here. Let's see, can I zoom in some more? It's a reasonably, it's a good finish. I mean, overall, it really is. You can see there's really no humps and bumps here. It's a pretty good finish for, pretty much its whole way through there. So yeah, I'm trying to, yeah, there you go. You can see it's pretty good. So I'm absolutely satisfied with the finish quality. Again, not that it's terribly important for what we're doing here, but the finish quality is good. There's my tool held up. And I don't know if I was explaining, I don't remember. This is done in segments, of course. You want to keep your tool pressure as low as you can on this, because chattering is or can be a problem with this type of setup. I mean, I do what I can to control it. Like I said, I use double end bearings on both where possible. I purposely, when I'm doing a short bore, because I have enough length on the boring bars, obviously, I try to use longer standoff pieces that I weld in to keep it, again, to keep it spread out further apart. That helps to control the chatter, things like that. I know it's 2-inch bar in what is now roughly almost a 4-inch hole, but even so, you'd be surprised. The chattering you get can really be crazy. But no, our finish is good, and I'm right on my size. I was shooting for 9.975. I wound up I wound up with my tool here. I'm not gonna, well, you have to see the micro. I wound up at 9,974, so we're gonna be good with that. That's gonna be just dandy. So that's gonna essentially give me almost a 1/4 inch wall all around on my sleeve. My sleeve that's gonna be inserted and then welded. It'll be an almost 1/4 inch wall because the spring bushing that's going in there is 3.5. So, like I said, that's going to give me, again, it's a nominal 3.5. I'm going to squeeze it down to just slightly under because, again, you have that, you can get away with some discretion on this type of a bushing. And these, of course, these are 1 inch wide, so these are going to be stacked 2 deep from each side. It'll be 2 in from one side, 2 in from the other side, and that's the reason for the shoulder in the middle. It's a 3-inch pin, so these are, again, 3.5 OD, 3 ID, or nominally a 3 plus. I think they're about, even when they're squeezed in at their tightest, I think you got about a 8 or a 9,000 fudge factor on your ID. So, again, 2 from each side, and then I'll make the step I'll machine the step into the sleeve that will act as a stop for these bushings. I'll make it, again, just over 3 1/8, whatever. It's you know, you can almost pick a number, so there'll be no interference with the pin, you know, and certainly it'll still do its job to, you know, to hold the wall of this. I can't believe the one that was in there was just absolutely hammered. It really was. So even if I was toying with the idea of maybe welding this thing up or bore welding, number one, it'd be a pain in the ass to set the bore welder to weld around a step because I don't have that type of bore welder. But even with that, I mean, it would be a pain in the ass. And again, the results of that are just usually not so good. And this stuff is for a very good customer, and I really would rather not, you know, I don't want the job to go bad any quick. This stuff is under an extreme amount of I mean, I think as they described it to me, it's essentially a self-destructing machine once you start this thing up. I mean, these things are huge with these chains that are digging into the ground and these cutting wheels, and it's on tracks. It's like the equivalent of a 60 or an 80 ton excavator, the footprint of this. It's just, so again, I want as much durability as I can get, and I don't believe weld metal in a bore is going to make for maximum durability. At least my experience has shown me that it simply does not. So anyway, enough of that again. Segue. Sorry about that. So again, like I said, I'm going to be satisfied with that, and I'm going to get on now to making the. We're going to get a piece of material out, and we're going to start making the sleeve that will accommodate these and slide into here. Again, I'm just going to shoot for essentially just a light press fit into here, and that's about it. Again, no point in getting carried away because it is going to get welded. Now I'm not done here, so I'm not going to break this setup down. As I said, I'm going to counterbore these, and I'll do my best to try and show you that. I'm just going to essentially hand step the tool out and then feed it in rather than use the feed mechanism on the thing. I'm just going to hand feed it in with the carriage here. So you know, because again, it's not a precision operation. I'm making a counterbore so I can weld. And again, I'll put a nice big chamfer on the sleeve when I put that in. So again, I'll try to show you a little bit of that, and I guess I'll try to show you a couple of clips of some lathe work on making the sleeve. And we'll go from there. All right, so I'll bring it back as soon as I can. Thanks. All right, I'm just starting to make the sleeve, obviously. I had a piece of material here, and I figured just set it up. It's just raw stock material. I think it's a 4 series of steel. It's very weldable. It's, you know, not too bad on the machining part, you know. So I'm just trying to make it round. That's all. Just taking a nice light skim cut off of there, and then of course after that I'll start my boring. But I'm just trying to come up with my outside dimension right now. So I'll bring you back and forth as I'm going through this. But yeah, it's pretty decent material. It's machining pretty nicely. Didn't take a whole lot to get it all set up in the chuck here. yeah, like I say, I'll keep bringing you back as I go forward with this. Okay, some potentially good news. I've made a full cleaning cut on this, nice and round. In fact, I think from here to here, I'm about, I made it over length, of course, I'm about 5.5 or so inches from beginning to end of cut here, and I have less than a thousandths difference, and I'm completely clean all around. So this is 4-inch material. So I'm only showing, though I've got it completely clean, I'm only showing like 2 under 4 inches even, 2/1000 under 4 inches even. So I think what I'm going to do is this is going to be the sleeve, and I want a pretty decent wall on the sleeve. If you remember, if we come back over here, I said I wasn't going to break this down. The reason being, I think I was 949.74. I was shooting for 975. I didn't know what it was going to take to clean up the material I was going to make the sleeve. So now I think I'm going to take another cut on this and open this up a little. I'll bring this out about maybe, whatever, 985, take another 10 or something, or even a little more, 10 or 12 thousandths, and open this up a little to make the slide-in, the slide-in sleeve, the machine sleeve, a little bit, just to put that extra material in the wall of the sleeve. I think that would probably be a good idea. So I'm probably going to reset this up, take another cut, at least another cut on my bore here, and go from there. So I'm going to do that, and then I'll be bringing you back and forth. All right, I just figured I'd pause on that for a minute. What I'm doing first, before I go over and recut the bore on the knuckle itself, I figured I'd do some rough boring on this, just in case it gets knocked out of alignment or something, and I have to re-indicate it in the chuck and this and that. I figure I'll get the bore at least roughed out, and then let that cool a bit, and then I'll walk over and. I think I'm going to be just fine. I just figured, discretion is the better part of valor. Let me get this bore roughed out a bit, and then I'll go over and make the cut on the knuckle piece itself. So that's where I am at now. So I'm just going to rough this thing out. I'm going to bring it close, and I got to pay attention. I'm going to rough it out just a little bit beyond the pin size, because again, there's going to be a step in there. There's going to be a stair step in the center of this thing. So I'll have to be mindful of that. I can't get too carried away. So we'll work on that a little bit, and I'll bring you back. Okay, so I've made I've made some a fair amount of chips and smoke and heat, and I've coursed this out to my preliminary number, let's call it, which is my pin size, 3-inch. So I've coursed this out to 3-inch, and let me just kick this out here into neutral. And as you can, maybe you can see, I don't know. It went pretty well. It didn't knock anything out of alignment. So I guess this is going to be fine. So now that I have this number, this coursed out, I'll go back over to the to the knuckle and probably make another cut. Because again, what I'm trying to achieve here by doing this is I want this to have a pretty good wall thickness. So even after, so I want to come up almost, I should be almost a 1/4 inch wall thickness on this, which is, I'd like to be as close to that as I can. So there's certainly will be room enough in that, in that knuckle. Again, there's plenty of meat in there that I can take another cut on it, because again, I'm at 975. So I can certainly bring that up much closer to my 4 inches. So I will make another cut, even if it's for the sake of, another, 15 or more, 15, 18 thousandths. Because again, I'd like to have this, the wall thickness as thick as I can. So this is still burning hot. I'll just I'll let it cool and, you know, for a little bit, but I know now it's safe to go ahead and make my other cut. So I'll keep bringing you back as I go with this stuff.